Welcome back. This is our video solution to problem 8 from Superquiz 1. Hey, it's probably the shortest stated problem on the exam. We're trying to find an antiderivative, not necessarily elementary. Okay? Remember, this elementary phrase is talking about all the functions we know and love from essentially pre-calculus. Your trig functions, your exponentials, your logs, polynomials, right? Any sort of rational functions. All right, any function you pretty much know, right? That's your elementary functions. And we want to find an antiderivative for the cosine of e to the t, but maybe we aren't going to be able to do that using our elementary functions. Well, we have a really easy approach for doing that. So an antiderivative for the cosine of e to the t, well, we're going to write this down as an integral from 0 to x, or if we like, we could change the variables here, right? We could call this x over there or something, doesn't matter. But we have an integral from 0 to x of cosine of e to the t dt. Now, why do I claim this is actually an antiderivative? Because the first fundamental theorem of calculus, right, what we call FTOC 1, says if I differentiate this integral, I get the cosine of e to the x. Hey, that's not too shabby. Now, if you say, well, I wanted cosine of e to the t, and you gave me cosine of e to the x, okay, you can kind of play the game where you go in here and swap, right? You say, okay, let x go from 0 to t, this could be an x, and this could be an x. And now if you take the derivative with respect to t, right, and you swap all these things around, all right, so that's now a t, and that's an x, and this is an x. Okay, oh, that was already an x. It should have been a t, huh? If I take this derivative, now this will be the cosine of e to the t. Okay, so it's not that hard to fiddle around with the notation until it matches precisely what you want, right? But the big idea here is we may not be able to find an exact function in terms of the elementary functions we know, which is an antiderivative for cosine of e to the t, but this is a legitimate function, right? It's a function of t, right? And its derivative does equal cosine of e to the t. And sometimes that's just the best we're going to do.